So vectors in class 12 CBSE syllabus, what is there that you need to know before you start the topic? Vectors and scalars. Little bit idea those who are physics students they got the idea in class 11. Magnitude and direction of vector, direction cosines, direction ratios of a vector, types of vectors, equal, unit, zero, parallel, collinear vectors, position vector of a point, negative of a vector, components of a vector, addition of vectors, multiplication by a scalar, position vector of a point, and then section formula, dividing a line segment in a given ratio, definition, geometrical interpretation, properties, application of scalar product of vectors and cross product of vectors. This is there in your syllabus. So you learn all these things one by one, but this is not for the sake of any other subject. This is for the sake of mathematics, and that for CBSE board class 12 examination. The way I'll explain it to you, you need to learn it. It will be faster than the way you did in class 11 physics, those who have done it before. But you will understand everything, every step of it, I hope. I'll be starting from beginning only. So let me tell you, the scalar and vector quantities, you have the idea. Scalar quantities have no direction, vector quantities have direction. In physics, those who have seen vector quantities as force, acceleration, momentum, angular momentum, all these things. Here vectors have mathematical representation. Physical meaning will have little bit scope of it to state, but otherwise we will avoid that. Okay, it is just a mathematical construct for you. Clear? Application you will find every page of physics in class 12 physics. You will find application in other subject also. Right now we just do it as a mathematical construct. What is a vector? We will define first. A vector is a directed line segment. So this one is a vector, it's a segment. It is bounded between two fixed points. That's why it is a vector, and we write r equal to AB, which is bounded between two fixed points. Okay. So remember this definition of vector is a directed line segment. This is called the initial point or starting point, or you can refer this one as tail of the vector. Tail. This point A is tail, and the point B will be referred as tip of the vector. Tail and tip. Origin. This can be referred, this tail can be referred as origin also. Initial point or tail or origin, and B is known as tip. It's a directed line segment because bounded between two fixed points. If it has length 10 centimeter, we will say that magnitude or modulus is 10. Then what is magnitude or modulus of a vector? Magnitude or modulus of vector A is the length of a vector. Length of a vector length of a vector is known as its magnitude or modulus. Length of a vector is known as its magnitude or modulus of the vector. So modulus of vector A, we will write this manner, mod A. Length of the vector is modulus or magnitude. Now the vector has a fixed direction. In our diagram, the vector directed from the point A to the point B. But vector can be directed in opposite manner also. It may be directed from B to A, and assume they are of same length, these two, AB or BA, in both the cases same. Then you will be writing AB equal to minus BA. Or one can write VA vector equal to minus AB vector. This will be referring as negative of a vector. Negative of a vector is also a vector, just direction is opposite. If AB equal to R vector, we will be writing BA as minus R. Let AB equal to R, then BA will be minus R. It's like this, just direction is opposite. Now there are different types of vectors. Types of a vector. We cannot categorize this way because according to application we will find some vector in some other subject. Those have no application here, so I will remain silent about those. Like angular momentum vector, we don't study here. Torque vector, we will not study here. Okay? So types of vector will just state what are co-initial vectors, what are collinear vectors, and what are coplanar vectors. These two vectors, if we refer them as A and B, they are called co-initial vectors. This type 1. Co-initial vectors. Okay? There is an angle between them, they are not coincident, they are starting from same point. You can take another vector also. That vector be OC. OA we have taken A vector, OB we have taken B vector, OC is another vector. So these three vectors A, B and C are co-initial vectors because they have the same starting points. That's why they are called co-initial vectors. Then vectors can be parallel also. If two vectors have same direction, then they are said to be parallel. Okay? In this diagram, A and B, these two vectors are parallel. Two vectors are said to be parallel if they have the same direction. So they have same direction, we have done accordingly. So in this diagram, A vector parallel to vector B, or B is parallel to A. Okay. There may be collinear vectors also. What are collinear vectors? Two vectors lie on the same line, then they are said to be collinear vectors. OA and OB, they are collinear. This OA vector equal to A and OB vector equal to B, they are called collinear vectors. These two vectors are collinear, vector A and vector B. What are those vectors? OA and OB. Now, one thing we have to make clear, that a vector has no position. I mean, we can draw it anywhere. Anywhere means by moving it parallel to itself, we can take it at any place. We can move in forward direction also. So by keeping the direction same, a vector can be slid. This is a very important property. We will note it down, that a vector can be slid, translated parallel to itself. Okay, we can slid a vector parallel to itself. So in this context, if a vector A is here and a vector B is here, see, they are not parallel. And what is the result if we slid them from one point to another point? Or if we want to meet them at a point, how can I do this? See, I have taken it here. This vector A, which was there, I have taken it here. I can do it. Can be done. We can make them coincide easily just by moving parallel to itself in the same direction or really parallel to it. This is a very important property. In case of addition of two vectors, this will play a very important role. So remember, never forget this. It's a very important concept in vector. A vector can be slid parallel to itself. Okay. Now tell me another thing. If I slid A parallel to B, finally I am taking it towards B, moving it towards B, then what will happen? A will be coincident with B. So when you say two vectors are parallel or two vectors are collinear, there is no difference between these two. Okay, in vector algebra, this I will say vector algebra. In vector algebra, as a vector can be slid parallel to itself, so we say that all parallel vectors are collinear vectors. Similarly, collinear vectors are parallel also. I am not talking about anti-parallel case. Anti-parallel means one vector directed this way. Suppose this is R1 and another vector this way. We can make them also collinear, but our purpose is just to understand the topic. Then this we treat as a problem. We can make them also collinear, but their direction will not be the same. They make 180-degree angle. Okay. So in that case, if we make this one to lie on this, then purpose will be different, which is normally used in case of physics. Here it is of no use. Okay. Just if we take on it, then there will be vector subtraction. Okay. Now we will learn multiplication of a vector by a scalar. Let us learn it. Multiplication by a scalar. Multiplication of a vector by a scalar. We are going to multiply a vector by a scalar. It is very simple. If there is a vector A and we are multiplying by 2, multiplying A by 2, what do we get? We will get a vector which is 2A. This vector is 2A. Multiplying A by half, what do you get? It's a vector in the same direction, but magnitude is half of this. In this case, magnitude was doubled. So in step 1 we have multiplied by 2, step 2 we have multiplied by half. Then you get half a vector. Okay? We can multiply this by a constant. Suppose you are multiplying A by minus 2. What do you get? We get minus 2A. But minus 2A, double the magnitude of A vector, but its direction will be different. This is minus 2A. Clear? So now you just do one experiment. Suppose there is a vector A of magnitude 5. Okay? Mod A equal to 5. Let A be a vector and mod A equal to 5. Can you represent 1 by 5 A vector? Is it possible? Yes, we can do it. The way we have divided previously, just magnitude will be 1/5. So if there is a vector A of magnitude 5 unit, this is 1, 2, 3, 4, 5. Suppose this is a vector A. This vector we have taken, say PQ. PQ is a vector. Okay? We are answering this way. Let A equal to PQ vector. Okay? Now 1/5 of A. 1/5 of A will get the vector of magnitude 1 unit along A. So this will be 1/5 of A vector. Okay? 1/5 of A vector. So this vector by now will be referring as A cap. A cap or A hat. This is called unit vector. This is called unit vector along the direction of a given vector. Okay? A hat. So in this case, A hat going to be what? A by 5. What is magnitude of A hat? In every case, it is mod A by 5, but mod A was 5. So this is 1. So draw a conclusion here. Magnitude of an unit vector is always equal to 1. Magnitude of a unit vector is equal to 1. Clear? So you understand how to represent, if a vector given, how to represent its multiple. So one thing that I am just showing you, if this is vector A, what is the use of unit vector? I mean understanding of unit vector different way. Use of unit vector. Okay? Suppose A be a vector given, magnitude also given. A given means everything given. Question is, draw a vector of magnitude 20 unit. Draw a vector of magnitude 20 units along A. How can we do this? Only A vector is given. Okay. I just read the vector here. This is the given vector A. A is the given vector drawn here. A is this. To represent it, to represent a vector of magnitude 20 unit, we will find A hat or A cap. Okay. This is A cap. A equal to this, A cap equal to this, divided by its magnitude. Then 20 A cap is here. What? You just magnify A cap 20 times. Okay. So this vector has representation this manner: 20 A cap or 20 multiplied A by mod A. Clear? This is A hat or A cap. So one thing, any vector of certain magnitude along the direction of given vector, we can draw just multiplying the unit vector by the scalar. If m unit is required, then we will multiply by m. This unit vector will be multiplied by m. 20 units required, that's why we have multiplied by 20 A cap. If 10 units but opposite direction is required, you just produce the unit vector in opposite direction 10 times. Okay? Then this may be minus 10 A cap. This we are supposed to draw a vector of magnitude 10 unit opposite to the direction of vector A. Okay? But parallel to it. So one thing is very clear, that if there is a vector A and if there is a vector B, then there is a relation between these two vectors. What is that relation? Relation between two parallel vectors. What's the relation? For two parallel vectors, one is the scalar multiple of the other. Why? Because B vector is some scalar into A cap, isn't it? Why? Why it is like this? You can write A vector this manner by now. Let mod A is equal to magnitude of A. Then A is what? How can you write? Magnitude of A into A cap. You agree or not? Take a unit vector in this direction, multiply it by magnitude of A, then you get A vector. B vector will be what? Tell. Magnitude of B into A cap. Clear? So what's the relation between them? You take the vector A from here, A cap is A by mod A. You just put it there. Mod B, A by mod A. So B vector is what? Mod B by mod A into A. This implies that B equal to m into, wait a minute, this you have taken A vector, no? You can write B vector equal to m into A vector. Clear? This is another very important concept. Okay? Two vectors are parallel if one of them is the scalar multiple of the other. This you never forget. Clear? Now addition of two vectors. How can you add two vectors? We want to add two vectors. This can be done by triangle law of addition. What is that? This is triangle law of addition of two vectors. This is vector A, this is vector B. Then if we add these two, we will get another vector, C, which is just taken in opposite manner. I mean, if two vectors, these two vectors A and B are represented by the sides AB and BC of triangle ABC, then third side taken in opposite direction will represent the sum of two vectors. So what we have done there, in diagram AB equal to A and BC equal to B, then sum of these two vectors, we are adding these two vectors, then A plus B will be given by AC. Okay? So the third side taken in opposite way will represent the sum of these two vectors. This is called triangle law of addition of two vectors. Okay? I told you this is going to be a mathematical construct. I cannot take the help of a practical example always. Just I can tell you, particle moves from A to B, then it goes from B to C. What is the displacement of the particle? A to B and then from B to C. That displacement is given by the third side of the triangle, that is vector C. This is a very common. Okay, this is a very common example. This will be true for force vector. This will be true for what other vectors? Obey the triangle law. I remember force vector now, being a mathematics teacher. You should decide, being a physics student, what other cases we can use the triangle law of addition of two vectors. Very good application is in case of displacement. Then we can go for force vector. But more than that I cannot discuss here. Okay? So the third vector will represent the sum of the two vectors, if the vectors given this manner. So based on this, I can represent a vector in two dimensions. Okay? So we are going to do representation of a vector in 2D. How to represent a vector in two-dimensional coordinate system. There is a vector I showed you. Vector may be anywhere. This you want to represent in 2D. 2D means two-dimensional coordinate system. This whole computer board is two-dimensional coordinate system only, because this is a plane. We want to represent this vector in the plane of this paper. How to do it? We will be drawing from the tail of the vector mutually perpendicular axis. This is x-axis and this one perpendicular to x-axis is going to be y-axis, you know. Okay? But this one was a vector. Vector was OA. We wanted to represent in this two-dimensional coordinate system. So see, I am going to link scalar quantity with vectors. But here, as it is in two dimension, if I tell you represent this one in along x-axis, that you can do. Just take a unit vector along x-axis and multiply by its magnitude. But in 2D, you have to see that it is somehow directed along y-axis also, or in between these two. So that only along x-axis will not work. Better we think about unit vector along x-axis and unit vectors along y-axis. So let r equal to OA be a given vectors. Be a given vector. Okay. To represent it, in 2D, we take unit vectors along x and y axis, because I told you that representation you cannot ignore y axis, neither you ignore x axis nor y axis. It will be in terms of unit vector in these two directions. Then proper representation in 2D is possible. To represent in 2D, we take unit vectors along x and y axis. Along x axis, we take I cap the unit vector, we take j cap as the unit vector. Okay, this we have taken origin. So in 2D, every point has a coordinate, the tip also has a coordinate. Let the tip be at axy. Draw a perpendicular from here. AL is a perpendicular. Let coordinate of A, general coordinate xy. So if you draw perpendicular, this is perpendicular. In figure, OL equal to x and LA equal to y. So what is OL vector? The magnitude given. We want to change this one into vector. We need a unit vector in that direction. What is it? That is I cap. Unit vector in that direction is I cap. Okay? So OL vector going to be x into I cap. LA vector going to be what? Y into j cap. Therefore, now in triangle OLA, OL is what? LA is what? Y into j cap. So the vector we have represented. How did I get this relation? This is by triangle law. This we got by triangle law. OA equal to OL plus LA, that is xi plus yj. So the vector R is xi plus yj. Clear? So vector represented in 2D in terms of the unit vectors along x and y axis. This x is here, y is here, and the given vector is now xi plus yj. What x stands for? X, by now you can see the diagram. X is along x axis, y is along y axis. So we will be referring x as the x component. Here x will be referred as x component and y will be referred as y component. Okay? X stands for x component. X component means x stands for x component. It means the component of the vector along x axis. The effective part of the vector along x axis is x component. Okay? Or we can refer this one as horizontal component. Clear? You can state this also. Then y stands for what? Y is y component This is better known as vertical component. Okay, so x is the x component or horizontal component, y is the y component or vertical component. In 3D, what is going to happen? In 3D, this you take x, y and z. Unit vector this way I cap, j cap and k cap. Okay, so a vector we can represent this way. This is OA, R is the vector. Similarly, like that we can write R equal to xi plus yj plus zk. Okay, so how do you realize x, y and z component? Hope all of you have done 3D geometry in class 11, because you are mathematics student. 3D geometry was there in mathematics class 11 syllabus, and that I know all of you have done. So if we do it in 3D, then R is xi, yj, zk. But what is x, what is y and what is z? This you need to understand. From like the previous one, if you have drawn perpendicular here, along x-axis x, along y-axis y. So if you draw a perpendicular here, this is three-dimensional view. Perpendicular may be like this. Here the perpendicular is like this. And here also perpendicular can be drawn on z-axis. This angle is 90 degree. This part will be referring as x, this part y, and this part z. A, B, C. Clear? Whenever you draw perpendicular, its distance from origin is x. This is a class 11 concept. So there, how to represent the vector then? By knowing this. This you have to make clear. How to do that? So I am simplifying my diagram over there. This is the vector OA x, y, z. We want to represent it in 3D. Instead of drawing perpendicular on x-axis, I am drawing perpendicular on xz plane first. This concept was also there. Understanding x, y, z can be done this way also. Draw a perpendicular here, AL. Then from L, you draw a perpendicular here. Okay. Draw a perpendicular here also. Okay. Then this part, if you join this also, then this is x, this is z, and this is y. But in this diagram, you see OA vector, this perpendicular you have drawn, let it be R. So OR is equal to x. In this diagram, OA vector is what? If you go by triangle law, complete the triangle. OA vector is what? OL plus LA vector. This part is y, it is lying along y-axis. OL vector is what? OR plus RL. Okay. So this will be what? OR plus RL plus LA. OR is what? OR vector. This will be xi, and RL, this will be z coordinate. No, z into k plus what? LA. LA stands for what? LA is y. yj. So again here also r equal to xi yj zk. Its magnitude at this moment only I can prove it is under root x square plus y square plus z square. Okay, done. What is modulus in two-dimensional vector? That will be root over x square plus y square. In 3D it is under root x square plus y square plus z square. In 2D it will be under root x square plus y square only. Now, if I ask you to write the angle made by the vector with x-axis, this is the perpendicular I told where it intersect. This angle will be referring as direction. This angle will be referring as angle made by the vector r equal to a with x-axis. We cannot find without a diagram here. In this triangle ARO or ORA, this angle 90 degree. In triangle ORA, cos alpha we can find easily. X by r. X by r means x by mod r. X by root over x square plus y square plus z square. This is y square plus z square. Sometimes we denote by L. Okay. This is called direction cosine of the vector. This is called direction cosine So the basic definition is cosine of the angle with x-axis. Similarly, if you draw a beta diagram, m equal to cos beta equal to y by under root this is called another direction cosine. Beta is what? Beta is the angle made by the vector with y-axis. Angle made by the vector with y-axis. This is cos beta, this is called direction cosine. Similarly, we can define n equal to cos gamma, another direction cosine. It's not new. Cos gamma, another direction cosine, it is given by z by x square, y square, z square. Gamma stands for what? Gamma stands for angle made by the vector with z axis. Clear? So these are called, I have given you the proof in one case. You can realize the proof easily by using this cuboid. This is going to be cuboid. Yeah. So in this cuboid, if this one is along x-axis, along y-axis, and this is along z-axis, and r equal to OP with the vector. The vector is this. R equal to OP is the vector. So this angle, if you join from here to here, this angle has to be 90 degree. This part x, this part z, this part y. Okay, if you draw a perpendicular, this MP equal to y. So here you can understand better way how cos alpha is x by r, because this is 90 degree. So cos alpha has to be x by r based by the length of hypotenuse. This is hypotenuse, this is 90 degree, no? So this is hypotenuse. Understood? Direction cosines, then we list A equal to cos alpha x by under root sigma x square, cos beta y by under root, and cos gamma, oh sorry, this will be y, and you write sigma x square only, and cos gamma z by under root sigma x square. Clear? These are direction cosines, and it is very obvious that L square plus m square plus n square by sigma x square means that only the result will be 1. Okay? So L square plus m square plus n square equal to 1. This we can apply in solving sums. But wait for solving sums. Let us now learn position vector of a point. Position vector of a point. How can you write position vector of a point? Position vector of a point. What is the meaning of it? So are we going to represent a point over there? No, we are not going to represent a point. We are going to find the position of point with respect to 2 or 3 dimensional coordinate system by using the concept of vector. Okay, what is that? Let A be a given point whose position vector A. What do you mean? There is a origin. Origin to A, if you join, this will be vector A. Is it clear? If position vector of the point A is A, then OA has to be a vector. There will be another point B whose position vector is B. What is the meaning? That OB equal to P. So start this manner. Let position vectors of the points A and B respectively. Okay? Position vector of the points A and B be A and B respectively. Then O is the origin. O stands for origin. Position vector of A, you have taken A. So OA should be A. And OB should be B vector. OA is A vector and OB is B vector. Now join this A and B point, these 2 points you join. Okay? Position vector concept is clear. From origin to that, if you join, the vector is position vector. Not the point. Position vector is a vector directing from origin to the given point. Origin may be anywhere. Origin may be in this plane of paper, origin may be outside, origin may be at infinite distance. But from that origin to A, if you join, then you will get the vector A. Clear? Now, we are going to do something more. Join AB. Join A and B. So, a triangle is complete. In this completed triangle, you can write OA plus AB equal to OB. So AB is what? OB minus OA, B minus A. Therefore, AB vector we got B minus A. This B stands for what? That is position vector of B minus position vector of A. Position vector of B minus position vector of point A. This is now formula. If we have AB vector, it will be position vector of B minus position vector of A. If we have PQ vector, how will I write? Acha, this you write position vector of B, no? So you write position vector of B minus position. How to write this? It will be position vector of Q minus position vector of P. Clear? This will be PQ vector. Now on this line, if there is a point which divides the line segment joining these two in the ratio m is to n, we are going to find the coordinate of that point. This will be referred as section formula. Okay? This will be referring as section formula. This point A is there, position vector A, B is there, position vector of B. Join these two. You want to find position vector of the point P which divides AB in the ratio m is to n. Okay? We are going to discuss about section formula. Join this. This is A and this is B, obviously. We want to find position vector of this point R, P. The point is position vector B, R. To find it, we just observe that these 3 points are collinear. Okay? Section formula, position vector of P is required. So in this diagram, AP by PB equal to M by N. This implies AP equal to, N into AP. You should agree with me. Now AP vector is what? AP vector, position vector, we have taken R. So N into position vector of P, PV of A. Minus position vector of P. You just put it here. Check what is happening. Just put. Position vector of P, we have taken R. This is A. B, we have taken B. And this is R. Isn't it? Done? Now take all R's together. NR, MR, MB plus NA. So you find R from here. This R I am writing here. R equal to M into B, this by M plus N. This is the section formula. And position vector of P, if P be the midpoint, then you can take M is to N equal to 1:1. Midpoint formula will be what? Midpoint formula. If P be the midpoint of AB, then position vector of P 1:1, 1 into B plus 1 into A by 1 plus 1. That is A plus B by 2. Clear? This way, section formula of vectors can be decided. So this is elementary part of vector. Under what condition? Vector parallel, vector perpendicular. No, perpendicular we learn in dot product. Now suppose I am asking you a question given this manner. Just few simple example. Write a vector of magnitude 10 units along I plus 4j plus 5t. You have to write a unit vector of magnitude 10 units along this. How to write it? The answer will be what? We know how to find unit vector. Then multiply it by 10. Same concept. It will be 10 into n cap. N cap is the unit vector along this. How will I get it? 3i this by modulus of this root over 3 square, 4 square, 5 square. So this will be 10 into by root 50. You can cancel a bit. You write 10 into root 2 by 50 3i, 4j and 5k. So this is root 2 by 5 into this unit vector along the direction of the given vector. Okay. Now if I tell you to derive the formula for centroid of a triangle by using the concept you got so far, CG of a triangle whose vertices, I mean position vectors, whose vertices are known. Known means just you take a point or position vector concept, just do it. Center of gravity of a triangle whose vertices are known. See how the concept so far we have learned help us. Just a minute. Just give me 1 minute time, I'll settle it down. Yes, it has come again. Yes, to find center of gravity of a triangle whose vertices are known. Take position vector of three vertices as A, B and C. Center of gravity means it will divide a median in the ratio 2:1. AM is the median, BN is another median, CL is the other median. And you know, this is basic property that median will divide in the ratio 2:1. I mean, centroid will divide, the meeting point of medians will divide this median in the ratio 2:1. Position vector of three vertices are given. Position vector of A is A and C is C only. What is position vector of M? We are going to solve it now. M is the midpoint of BC. So position vector of M will be that midpoint formula we have learned just now. It will be B plus C by 2. Now go by section formula as G divides AM in the ratio 2:1. M is what? M we got here B plus C divided by 2. So position vector of G 2 into B plus C by 2 plus 1 into A by 2 plus 1. Okay. So there it will be or A plus B plus C by 3. Hope you have understood. These are simple applications. Get ready for solving more problems on this basic concept of vector. This is the basic concept you need for board. But CBSE board syllabus and your JEE main syllabus, basically there is no difference. Okay, they don't give anything extra from these topics. So if you learn this thing properly, it will help you for your JEE preparation also.